Students, welcome to today's lecture. In this lecture I am going to discuss about beta and gamma functions. Okay, beta and gamma functions are the integral functions only. These are helpful in solving the complex integrals. Complex integrals means what? These are the integrals which are not able to solve using our normal traditional methods, means using our standard formulas of integrals. In such cases we use the beta gamma functions. Okay, these two functions are also called as functions of Euler's integral of first and second kind respectively. Now let us see what are the formulas for beta and gamma functions. So beta of mn is equal to integration from 0 to infinity x raised to m minus 1 into 1 minus x raised to n minus 1 dx, where n is greater than 0. Such type of functions are called as beta function. And gamma function is gamma of n is equal to integration from 0 to infinity e raised to minus x raised to n minus 1 dx, where n greater than 0 is called as gamma function. When you see both the formulas for beta and gamma, in the beta function we have two values. Those are m and n and one variable x. And this function is defined for positive integer. That is what n greater than 0 they have mentioned. Okay. Now gamma function is for one variable and one value n. Now we'll study some of the properties of beta and gamma function. First one is beta of mn equal to beta of nm, and gamma of n plus 1 equal to gamma of n into gamma n, or that can be written as gamma n equal to gamma n plus 1 by n. And don't get confused with the symbol of gamma and root. Gamma is different and root is different. And we know gamma n definition is integration from 0 to infinity e raised to minus x raised to n minus 1 dx. Now in place of n, if you write n plus 1, what happens? So gamma of n plus 1 is equal to integration from 0 to infinity e raised to minus x raised to, in place of n we have to put n plus 1. So n plus 1 minus 1 dx. This gives us integration from 0 to infinity e raised to minus x raised to n dx. Now integrate this by parts. Consider x raised to n as a first function and e raised to minus x as a second function. Then we'll get x raised to n into minus e raised to minus x, and integration from 0 to infinity, minus of minus plus, integration from 0 to infinity e raised to minus x, differentiation of n x raised to n, that is n into x raised to n minus 1 dx. So for the first part, when you put limits, it becomes 0, and in the second part take n outside, then integral from 0 to infinity e raised to minus x raised to n minus 1 dx is what? Is nothing but the definition of your gamma n. Okay. So therefore second part is what? N into gamma n. So this is how you can write gamma n plus 1 is equal to n into gamma n. So second property I have written it as gamma n plus 1 equal to n into gamma n, that I showed. Okay. gamma n plus 1 equal to n gamma n ಹೇಗೆ ಬಂತು ಅಂತ ಇವಾಗ ನೋಡಿದ್ರಿ. ಅದೇ gamma n ಅನ್ನು ನಾವು gamma n plus 1 by n ಅಂತಾನೂ ಬರೀಬಹುದು. You can use these accordingly whenever we need those solving the examples. Okay. Now gamma n plus 1 ಇವಾಗ ಏನು ಮಾಡಿದ್ರಲ್ಲ ಅದೇ ಪ್ರಕಾರ ಇಂಟಿಗ್ರಲ್ ಫಾರ್ಮಲ್ಲಿ ಹೇಗೆ ಬರೀಬೋದು? We can write it in the integral form as 0 to infinity e raised to minus x raised to n dx for n greater than 0. And another property is gamma of 1 is equal to 1. How we got? I have written in the right side. Gamma n iddalli gamma 1 ಹಾಕ್ರಿ n ಇದ್ದಲ್ಲಿ, and integrate, you will get a 1. Okay. Now using gamma n plus 1 equal to n into gamma n successively means what? Go on putting n values in the above equation. What happens when you put n equal to 1? LHS is 1 plus 1 gamma 2. So then 1 into gamma 1. Gamma 1 we know it is 1. So 1 into 1 is 1. Okay. So now gamma, when put n equal to 2, it becomes gamma 3. So n into n means 2 into gamma n. So 2 into gamma 2 is what? 1. So you can write 1 as a 1 factorial. Okay. Now 1 factorial. 2 into 1 factorial is 2 factorial. Same. Put n equal to 3 in the LHS. You will get gamma 4. Then 3 into gamma of 3. So from previous step we have got gamma 3 as 3 into 2 factorial. 3 into 2 factorial is nothing but what? It is 3 factorial. Okay. Likewise, you can write gamma n is equal to what now? So gamma n plus 1 is equal to, we can write it as n factorial. So gamma n plus 1 equal to n into gamma n is equal to n factorial. So all these three are equal. Okay. ಯಾವಾಗ ಯಾವ ರೀತಿ ನಮಗೆ ಸೊಲ್ಯೂಷನ್ ರಿಕ್ವೈರ್ಡ್ ಇರುತ್ತೋ ಆ ಟೈಮಲ್ಲಿ ನಾವು ಈ ಈಕ್ವಾಲಿಟೀಸನ್ನು ರಿಪ್ಲೇಸ್ ಮಾಡಿ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಓಕೆ. ನಾವು we'll discuss another property, that is beta of m comma n is equal to 2 times integral from 0 to pi by 2 sin raised to 2m minus 1 of theta into cos raised to 2n minus 1 theta into d theta. This is one property of beta function. Another property of beta function is beta of mn. It can be written as integration from 0 to infinity t raised to m minus 1 divided by 1 plus t raised to m plus n dt. This is equal to 0 to infinity t raised to n minus 1 is divided by 1 plus t raised to m plus n dt. Very first property was beta mn equal to beta nm. So integral also in terms of n and in terms of m for t. And one more property for gamma n in terms of t is 2 times integral from 0 to infinity e raised to minus t square t raised to 2n minus 1 into dt. How we got this by replacing or putting x as t square, okay, by substitution method. And next one is gamma of 0 is equal to infinity. This is a standard result. We are not going to use this because we have defined this beta and gamma function for positive integer, that is n greater than 0. Still I felt you should know this, that's why this is a standard property, gamma of 0 is equal to infinity. Now we have discussed so far beta and gamma functions and the properties of beta and gamma functions. These are some standard properties, basic properties. So in the next video I am going to discuss about 2 more standard properties of both beta and gamma functions. Among them, one is gamma of 1 by 2 is equal to square root of pi. Okay, the question may be asked as, the format of the question is show that gamma of 1 by 2 is equal to square root of pi. Okay, this will be asked in your exams for 6 or 7 marks. And one more property is beta of mn equal to gamma m into gamma n divided by gamma of m plus n. That represents the relationship between beta and gamma functions. So we'll discuss both the properties in the next video. Till then, keep practicing. If you have any doubts, please comment in the comment box. If you are not yet subscribed, do subscribe my channel and support. Thank you.